Well, hello again everybody, and today we've got a Thandar TG502 and it's a 5 megahertz sweep function generator. Now, for reasons which are completely unknown to me, I suddenly got the urge to buy a sweep function generator, and this is what I came up with on eBay. So I bought this, waited a few days for it to arrive. I was that desperate to play with it. I plugged it in at work and I was greeted by the power light flashed on. I think a few of the other lights flashed on very briefly, and then smoke started to emerge from around the grill here where the cover meets the front panel, and then it went off because the fuse had obviously blown in the back. Is this the kind of thing that we can take a guess on? I think we can probably almost pretty much guess what's gone wrong with this. It's almost certainly, come on, place your bets. I think number one, Duff tantalum capacitor somewhere. Number two, Duff regulator. Number three, Duff electrolytic somewhere. And number four, I'm going for an X-rated capacitor across the mains. Those are my predictions, so it's likely to be none of them. I just wonder what the fuse value actually is. Let me just have a look at that. I think I looked earlier, I couldn't read it, the writing's tiny, my eyes are getting rubbish. I'm going to go for time delay 120 milliamps, and the way that the wire has gone is I can see that the wire has melted, but it hasn't vaporised against the shell of the fuse. Quite often when you get an X capacitor failed, X capacitors are generally wired across the live and neutral. Typically when you get an X capacitor fail, it's a very hard short circuit that will draw so much current it will vaporise the metal inside the fuse, and it will it'll metalise it. It'll metalise the inside envelope of the fuse. So that hasn't happened. So this was blown a little slower tn that. So yeah, getting a bit Quincy me on this, aren't we? I used to love Quincy. Well, that's enough foreplay. It's about time we got inside her. Now, after it did let out the magic smoke, I immediately contacted the eBay seller, and I've got to admit, he sounded like a really nice bloke, and we kind of said, yeah, it's one of them things when you buy old tester gear, sometimes it does just break. So I said I'd be willing to have a look at it, as long as he didn't mind me opening it up. So basically he said, by all means, open it up, have a look and tell me what we find. And he said, whatever's wrong with it, don't worry, we'll sort it out. So he seemed like a nice fella, and we will just take him at his word. So the first thing I would say is, it stinks. It really smells of burn, which is strange because whatever failed went absolutely instantly. And I wonder if there's any evidence on the inside of the case. Sometimes you can see some smoke. No, can't see anything. I think there's more than one board on here, so I'm wondering if I need to undo the bottom panel as well. I think I probably do, because it could be the top panel or it could be the bottom panel that's gone. Something there looks a little bit funny. It's a couple of transistors which are look as though they're facing each other with, I don't know, it looks like they've got heatsink compound, so it looks like they're doing some kind of thermal matching. So we've got the usual suspects. We've got quite a few tantalum capacitors, and I'm looking for one that's showing any signs of discoloration. I'm not seeing anything at the moment. Now, I have to admit, I paid a reasonable amount of money for this signal generator. I paid much more than it's worth. Actually, I don't know why I did pay so much. It was one of those drunken things. You know, I bought it at the time and regretted it afterwards. And you know, these things aren't worth a lot of money. But of course, if you suddenly need to buy one at any particular moment in time, you know that you pay the premium, don't you? And I paid the premium because I wanted it then, but definitely paid more for this than I should. So I'm just doing a visual inspection as I talk, and I'm making a point at looking at all the tantalums I can see, because I was hoping I would see a a burn mark or a scorch mark on one of these. And I was also looking for some XY caps across the mains, well, an X cap across the mains, a Y cap to earth for EMC. I'm not seeing any of them. There's a resistor down here that looks as though it's got a bit of a burn mark on it, but I don't think it is a burn mark. Ah, wait a minute. Okay, there's an electrolytic here. I'll see if I can bring you in. There is a mark on it, but I don't know if it's just where one of the stud wires has been welded on. It's a bit hard to tell. Let's see if I can bring you in. I'm trying to rub my finger on that, see if that matches the smell. Yeah, I'm just going to take the bottom cover off this, see if I can see anything burnt on this bottom board before I do too much testing. Because I'm sure that whatever's puked its guts up, I think it'll be visible, because quite a bit of smoke came out of here and it really stank to high heaven. So I think we should, you know, do one of them things that when we spot it, when we find out what's gone wrong, it's going to be really obvious, but yeah, until we find it. No, I'm not seeing anything on here. There's no tantalum capacitors on here. And the fact that there isn't any tantalum capacitors on it, you know, that's what I would be looking for. I've actually got an awful lot of ICs in here, but luckily they are all socketed. Ah, right, okay. Now that I wasn't expecting. Oh, sorry, we've got a resistor here which is burnt out. That's what it is. So hopefully you can see that there is a resistor here which is just a charred mess. And the problem is, of course, we don't have a circuit diagram for this, and I don't think there is any published diagrams anywhere, because I was having a look on the EV blog and there was other people looking for diagrams who hadn't found them either. So I'm wondering if this is going to be a relatively short repair, because that's obviously gone thermonuclear. It's melted, and yeah, that's basically it. That one is goodbye Vienna. I wonder if it's worth just cutting it out. I think we'll do that. We'll cut it out. Maybe if I cut that out, it'll at least allow the thing to power up. So far I've lost my bet, haven't I? Because I said it was going to be a tantalum, and it actually might be. So it's, for those playing at home, it's a bit hard to read the markings under it because it's actually burnt the board, but it looks as though it's R19 that's gone up. So that's resistor R19. I'm just going to clean that up with a little bit of alcohol. Oh, right, correction. It wasn't number R19 that had gone. It's R119. So that's R119 has puked its guts. Even though this thing is melted and charred, you never know, it might actually still give me a reading. Well, that's measuring 4 ohms. So I'm wondering if that is some kind of fuse resistor. Is that some kind of sacrificial resistor? It could be that's protecting some other part of the circuit. But unfortunately, the problem is, of course, that we don't know why that's burnt out. Resistors generally don't just fail like that. This has failed in response to a short circuit somewhere. So we could probably do with finding out what that's feeding. But I'm at a dilemma now, because I was pretty sure that all I was going to have to do is, you know, replace a couple of horrible tantalum capacitors, and I thought off we would go again. But it appears that you know, there's more going on than that. So one of the things I probably would want to do is check out some of the power supplies. So we've got some TTL logic on here. So we're going to find some 5 volt supplies, and I'm guessing we're also going to, because we've got some op amps on here, and because of the age of this equipment, I reckon we've probably also got positive and negative supplies for the op amp rails as well. We've also got a positive and negative DC offset control. So that again, that leads me to think that there's probably plus and minus supplies on here. So I've just connected my ohm meter probe to one side of that resistor, which I think is a supply rail. And I've basically just been poking about on the op amps, and I just googled a data sheet for this op amp, for example, which is an LF441CN, and I get continuity between this, what I think is a supply rail, and this pin on the op amp, and that's the same for all these op amps. So looking that up on the data sheet, that's a positive supply rail. So I'm guessing going back to this side of the circuit, which I think is duff, this has got something on the positive side of the supply rail that's pulling it down to ground. We don't know what that is, but yeah, there's something not right somewhere. Now I don't know for sure, but I'm really hoping that now we've cut this resistor out here, that the fault is on this right hand side of the circuit here, and that we've actually isolated it. So I'm fairly hopeful that when we power this up now, we're going to get our, whatever it is, I'm going to say plus 12 volts. I've got no idea what the supply rail voltage is. I'll probably just look that up in the spec for the op amp so we don't go too high. So I think what the thing to do now is we'll plug this into a variac and we will run it up and start to have a look at the supplies. Now I'm guessing that the first supply that's going to come up is probably the 5 volt rail. So we can look for the 5 volt rail coming up, and then we should be getting whatever they are, the plus 12s, minus 12s. Don't know what happen. I don't know what voltage they will be, but it's going to be probably something like that, plus or minus 12 volts. And then we can maybe check the other supply rails as well, see if they come up at what we might call logical voltage. Now, of course, the other fault that we could have is one of these power transistors. I think we said it was this one here. Is one of these transistors could be short circuit, and that may be us blowing up something on this side of the board, which has made it gone short. But I have just tested these transistors here in circuit, and you know, they haven't got any collector emitter shorts or anything like that. So I'm hopeful that they are going to regulate, but we'll turn the power up slowly, and we'll just have to keep an eye on our supply rails and look for anything disastrous going wrong. So we've got lots of electrical gubbins out now. So we've got the variac here, that's going into this lamp limiter, and we've also replaced a fuse in the back. So my plan is fairly simple. I'm just going to wind up the voltage a little bit, and I'm hoping that we're going to get some supplies on here. So let's have a go at that. And we are also getting some, I was going to say, we're getting any lights on. No, we don't get any lights on yet. But we've got 6 volts across that transformer. What's the voltage out here? Got 50 volts on there. Okay, we're at 100 volts now, and I think we might have some rails coming up. I'm just going to knock that off a second and transfer my test leads. So I'm just concentrating on what I'm doing because I don't want to electrocute myself particularly. That's always a bad start to the day. So I'm just wondering, have we got a 5 volt rail now? Okay, so that rail's regulating. Yeah, sorry about that. I was looking at that device and that was a 5 volt regulator over there. I bet you were all screaming at me, weren't you? What an idiot. Right, okay. So let's see what this... I think we said it was a plus rail. We're not sure what voltage it is, but no more than... I don't think I want to put more than 12 volts on it. So we are up at 15.39 volts now, and well, I'm not going to say it's working because, well, it's not, because we've still got half the circuit disconnected, but I'm fairly sure that it is now. You know, we're getting activity on the switches, and well, I think it is. I think it's doing something. So I guess the next stage is we need to try to find out what's shorted out on this. It's a minus 15 volt rail. There's something on the right hand side of the circuit, a dead short on the minus 15 volt rail. So we've got to investigate that. Some of these ICs are in sockets, So I think probably the easiest thing to do is to disconnect those ICs from the sockets. And we've also got a ribbon cable here which feeds the lower board. So I'm wondering if that lower board connector, it's worth just disconnecting the lower board to see if to see if the short circuit goes away, because we don't know if the short circuit is on the upper board or the lower board. So yeah, we've got to check that as well. Let me see if I can disconnect that lower board. So if I want to switch the power off, and I'm going to unplug as well, it's always safer, isn't it? So I've just isolated that board now. Now we've still got a short circuit, so something on this circuit here, something is being fed by R19, which has got a dead short. Now there's a couple of ways we could attack this. You know what my favourite trick is, don't you? Which is just to connect a separate power supply to it, and we'll run a separate minus 15 volt supply. We'll see what gets bloody hot, because hopefully it will clear the fault. Some component on here will get bloody hot, and we can go looking for the problem then. Or the other way we could do it is we could just try disconnecting all the socketed devices. It's almost certainly, there's some tantalums on this side of the board. It's almost certainly a tantalum. I mean, we know what they like, don't we, from history. It's always the tantalum. Let's just double check before I go sticking minus silly volts down it. Let me just double check my rails again. Okay, so it's the I've got them wires the right way around. Did I say I thought it was the minus supply? No, I've got plus written there. So it's a plus 15 volt supply that appears to have a short circuit on it. So my next step is, what I'm going to do is I'm going to connect up an external power supply, and I'm going to turn up the power. And to be honest, I'm going to see what blows. I'm going to see what gets hot, because somewhere on this plus 15 volt rail on this side of the board there's a dead short circuit. So I'm going to turn the power up a little bit, draw a bit of current, and then I'm going to do the finger test. And when I go ow, that's the problem. And I'm going to bet it's one of these evil tantalums. I think maybe I'm feeling a little bit of heat on that tant there. I'm going to use my usual trick, and I'm just going to cut the bugger out. See if it clears. Might do. Well, unfortunately it did actually take me quite a bit longer than I anticipated to find the problem, but it does turn out that I was right all along, in that it was a failed tantalum capacitor that was pulling down the plus 15 volt rail. So I've done what I normally do, is I've just cut the tantalum out, because to actually replace it I've got to take the board out to get at it, and to get the board out we've got to take all these controls off, and to be honest I don't want to do that now. So I've actually, I couldn't get this resistor back in, the one that had appeared to have burnt out, so I've actually just strapped a link wire across here, which isn't great, but it will do for testing purposes. So let's just put some power back on and give that a go. And it looks like we have been rewarded with a trace. So what have we got on there? So we've got sine wave, we've got square wave, got a triangular wave. Oh, that's quite nice. Let's put it back to there. We've got DC offset control. Let's try that. Well, that's amplitude, sorry. Okay, there's DC offset. Seems to clip. Okay, range isn't particularly good for that. Let's take the offset off. Got an amplitude control. Main frequency control. Yeah, so we can go up and down in frequency. And this unit isn't frequency synthesized, this one. It's not a digital synthesized generator. It is actually all analog, so in theory it should be quite a nice output waveform from this, which is ideally what you want when you're sweeping. Did I say that it's a sweep generator? Let's check some of the other frequency ranges. So that's a low frequency, 10 megs, 1 kilohertz, 10k, 100k, 1 meg. And let's go back to Oh, let's leave it on 1K actually. 1K. Because that seems to work. Right, the only problem that we've got now is I have been trying, and for the life of me, it doesn't matter what I press and what I do, I cannot make it sweep. Well, I couldn't get it to sweep at all, and just a couple of times I thought I did see it sweep. So what I've done is, again, just brute force over ignorance. I noticed that somebody's been in here before me, and I could see that some of the switches looked dirty. They'd certainly been cleaned in the past, because I could tell looking at the Bakelite they'd absorbed the oil. So I don't know what they were cleaned with or what they were sprayed with, but it looks as though they were sprayed with something which hasn't done them any good. And in fact, this pot here had some really sticky oily residue on it. So I've replaced all that. I've sprayed it all with contact cleaner with deoxit, and operated all the push switches, and I'm hoping you can see we're actually getting a sweep now. So I've got that to set, I can make that sweep slowly. You can see the frequency is very slowly increasing, and we can also, it's going back the other way now, and we can also make it sweep faster. Well, I'm just working my way through it at the moment, so you can see the dots moving forwards and backwards, which is a bit unusual for a scope, isn't it? Because they normally move along and then reappear, run round the back and come back this side. But it's actually going backwards and forwards at the moment, and the reason it's going backwards and forwards is because this dot, rather than being controlled by the internal time base, it's actually being controlled from the ramp voltage which is coming out of the sweep generator, because it's a ramp voltage, and I've got that going into channel 1, because it says here channel 1 or X. And X is like, it's like X and Y on the graph, X being this axis here. So if I unplug that, the dot disappears. If I plug it back in again, you can see it's moving backwards and forwards, and I can control the speed at which it runs backwards and forwards with this time control here. So we can slow it down or stop it, or we can turn him up. And I've pretty much set this. I haven't got it dead right, but you adjust the various position controls, so I believe so. The dot goes right to the end and then goes right to this end, so it shouldn't spend too much time off screen, it should just fit onto there. So I'm guessing that this would be the beginning of our sweep, whatever we set. I forgot what I said we set that. Say it's 10 megahertz, and then that might be 20 megahertz. So right in the bang in the middle there would be what did I say, would be 7.5. So if that's 5, that's 10, the middle would be 7.5. So I'm guessing that's how we set it. And then the other input here, this is what we would actually put as the input of our radio to test our filter response. So we're going to see all the input going in here now, and you can see it's modulating, it's moving the vertical, the y-axis up and down. So I'm guessing now if I actually just increase that, would you call that a raster? We're getting a scan now. We get an actual display. So of course this isn't a radio. This isn't a filter. So I'm guessing that's why we may be seeing full amplitude. I'm not exactly sure I've got it quite set right. I'm sure somebody like Simon, I think he's got a sweep generator, so he'll probably jump in and tell me how to do it. So I've got the actual 50 ohm output, I've got the actual frequency output going into channel 2 of the scope. Now we've got some markers here which I thought did something, but it says marker duration, doesn't seem to do anything. I think that's just idiot error. I think that's just me who doesn't know what he's doing. So maybe I still haven't quite got something set up right. What happens if we put it on AC? I thought we should get, when we turn the marker on, I thought what we should have got is like a highlighted dot here on the screen, which I don't know if that corresponds to the centre frequency or not. So I think we're moving in the right direction. We seem to have everything but our marker, but it's possible that the reason I haven't got a marker is because I've got something set up wrongly. So I think we've got this more or less functioning now, but I actually think to get it into a really usable state there's quite a bit more work to do on it. This board, circuit board on top, it's quite hard to get out. Even the transformer's bolted down to the top of it, and all the knobs and everything's got to come off because I've got to get at the board to remove all these duff tantalums and solder in some new main smoothing capacitors and stuff like that. So what I think I'm going to do is, I bought this on eBay as a working item and it clearly wasn't working. I've spent about a day on it. I did speak to the guy, I think I said earlier, and he seemed a really nice bloke and very genuine. And he said this was a piece of equipment that he'd had, but he hadn't used it for a few years. So I've got no reason to to doubt the fella. But it was quite a lot of money, this, and the amount of money that I paid for it, I expected it to work perfectly and not be a restoration job, which is what this is. This should have been spares or repair, and I would have been much happier to pay that kind of money. So I'm going to speak to the guy, and I'm hopefully he's going to accept a reasonable offer. Well, I'm not going to make him an offer. I'm going to let him decide how much he wants for it, and I'll decide whether I want to keep it or not, because I don't really want to invest that much time on it. For what I paid for it, I think he can probably have it back, because it's going to take quite a few hours to get this into the condition that I want it in. So that's enough of that for today. I know some of you have been following the CB repair. That is still going ahead. I haven't forgot about it like some of my other projects. You know, I like to give up as soon as the going gets tough. I haven't done that this time. It is still ongoing, but I can't remember if I said I've ordered one of these SAMS maintenance manuals from America, so that's going to take a few weeks to arrive, and so we're waiting for that to arrive, and then we'll try and do an alignment on it. And again, I was hoping that for some of these radios that I've got lined up, we might be able to use a sweep generator to do an alignment, and that's what was in the back of my head when I bought this. So hopefully we can get this going, or let's face it, I'll just go out and buy another one. And it could even be that some of these service monitors I've got a sweep generator built into them. I don't think the 2955 can sweep, but maybe the Stabilot can. I'm not sure. I'm going to have to read the dreaded manual. So I think that's a natural conclusion today. So as always, thanks very much for watching. Thanks for all your comments, I really enjoy them. I've got some good pals with you guys out there. It's always a laugh on the after show comments. And I guess that will do. So thanks very much for watching, and I hope to see you again soon. But until then, bye for now.